We're going to do some application of our basic trig functions. So here, if we've got angle T at 45 degrees, side U is 20, find the length of side T to the nearest tenth. Okay, so we got to think about sine, cosine, or tangent from this 45-degree angle. T is the opposite, U is the hypotenuse, so that is going to be sine. Okay, so we're doing sine of T, which is 45 degrees, so sine 45 degrees equals the opposite, which is T, over the hypotenuse, which is 20. So we just need to solve that. Okay, so now when we solve just using basic sine, cosine, and tangent, we first need to check our mode. We're in radians right now, so I'm going to go down and put that into degrees. And now I'm going to be able to solve this. To solve, all I have to do is multiply both sides by 20, so I'm just multiplying this across. So I get T is 20 times sine 45. And that is 14 point, and it says to the nearest tenth, so 14.1. I'm going to add a problem here between examples 1 and 2. Okay, so I'll make this 8. And this x, so that's what we're going to be looking for. And this angle right here, I'm going to have 45 degrees, 12 minutes, and 15 seconds. Okay, so we need to find the value of x. So this time I've got opposite, and I'm looking for adjacent. So that's going to be tangent. Tangent, 45 degrees. 12 minutes, 15 seconds equals the opposite over the adjacent. Okay, so this time I have, first of all, I've got degrees, minutes, seconds, so that's one way it looks different from up here. The other way is up here I had the variable in the numerator and I multiplied. This time I've got the variable in the denominator, and because one rule of proportions, which this right here is over 1, so it makes it a proportion. One rule of proportions is that I can always switch diagonally. It's just a shortcut, otherwise I would be multiplying both sides by x, then dividing both sides by tangent 45 degrees, 12 minutes, 15 seconds. So the shortcut, I'm just going to switch those, so I get x equals 8 divided by tangent 45 degrees, 12 minutes, 15 seconds. Okay, so in my calculator, 8 divided by tangent 45, then I'm going to go to angle, which is right here. It's the second function, second angle. I've got degrees. Did I even put in the 45? I did. Okay, so 45, option 1 is degrees. 12. And then option 2 is minutes, and then 15, and for seconds, it's right here, it is alpha plus. Alpha plus gives me seconds. So I've got 8 divided by tan 45 degrees, 12 minutes, 15 seconds, and to the nearest tenth, I get 7.9. Okay, find the apothem is, I don't have to find the apothem, the apothem is the measure of a line segment from the center of the polygon to the midpoint of one of its sides. Okay, so the apothem here is that segment. The apothem of a regular hexagon, in this particular one, is 2.6 centimeters. Find the radius of the circle circumscribed about the hexagon to the nearest tenth. So I want to find that length right there. Okay? So I've got a 90-degree angle. This says A degrees, and that actually goes right in here. And I can find that by doing 360 divided by the number of central angles that would fill this hexagon, which is 6. Okay, and 360 divided by 6 is 60. But right here, I'm just dealing with a half of a central angle. So 60 divided by 2 is 30. Okay, so I'm going to pull this triangle out, make it a separate drawing. So I've got that right angle. I've got 2.6 centimeters. I'm looking for this radius, and I've just found that this is 30 degrees. Okay, so this time I've got the adjacent and the hypotenuse, so I'm going to be using cosine. So cosine 30 is equal to the adjacent over the hypotenuse, 2.6 over r. Okay, once again, I have the variable in the denominator, so I'm going to switch these. So the radius equals 2.6 over cosine 30 degrees. 2.6 divided by cosine 30. And I get 3.0. So the radius is 3.0 centimeters. Now, I'm keeping that 0.0. Usually you'd think, oh, that just means 3. Well, usually I just like to keep that 0.0 to say it rounds to 3. It's not exactly 3. So that's my reason for keeping that 0.0. All right, one more problem here. So I want the value of x here. I've got an opposite and an adjacent, so that's going to be tangent. 28 degrees. That equals the opposite over the adjacent. Okay, and this is more like our first problem where we've got the variable in the numerator. So this time I just need to multiply this over to here. So I get x equals 348 times tangent 28 degrees. And I get 185.03. So rounded to the nearest tenth, like the rest of them, would be x equals 185.0. And this one does have units of feet, so 0.0 feet.
So now a little review to close out our lesson. If sine theta is root 56 over 9, find tangent theta. So here is a right triangle, and we'll put angle theta right there. Sine is opposite over hypotenuse, so that's the square root of 56. As the opposite, 9 is the hypotenuse. We want to know tangent theta, so that's opposite over adjacent. Okay, so we need to know adjacent. So square root of 56 squared plus b squared equals 9 squared. Okay, so we will subtract the square root of 56 squared. So 9 squared is 81 minus the square root of 56 squared, which is 56, and that's 25. So b squared is 25. So we take the square root and we get b is 5. So tangent theta is the square root of 56 over 5. Now, let's see if this can be simplified. 56 is 7 times 8. Okay, so we could go with square root of 7 times 8, and 8 is 4 times 2. So 7 times 4 times 2, and I'll just check that. 7 times 4 times 2 is 56. Okay, and that's all over 5. The square root of 4 is 2, and then 7 times 2 is 14. So square root of 56 is 2 times the square root of 14. And 2 over 5 does not simplify, so there is tangent theta. Okay, now we are looking for sine 300. 300 is going to go a little past 270, so right about there. Okay, so we'll make our right triangle right there. Okay, so our theta here is the reference angle, and we can get that by doing 360 minus 300, and that is 60. So this is a 60-degree angle, so we're looking at a 30, 60, 90 triangle. In a 30, 60, 90, the shortest leg is 1. The longest side, that's the hypotenuse, is 2. And the medium side here, the longer leg, is the square root of 3. Okay, now the legs can be positive or negative. The hypotenuse or the radius is always positive. Right is positive, down is negative, so it's actually negative square root of 3. So sine opposite over hypotenuse, or y over r. Okay, and I'm going to make note of that. Sine is opposite over hypotenuse. Opposite always comes from the y value. Hypotenuse is the radius. That is the square root of 3 over 2. Okay, then cosine 270. 270 is right here. Okay, so we'll make this a true unit circle where the radius is 1. And the coordinates here are 0, negative 1. Okay, now I made a note here that opposite is y, hypotenuse is r. Now cosine is adjacent over hypotenuse. Now I know hypotenuse is the radius. If opposite is the y value, then adjacent must be the x value. So x over r is cosine. Okay, so x over r is 0 over 1, which is 0.